Hey everyone, thanks for joining my talk. I'm happy to be here with great other for that shares the knowledge with others. Our talk today is how do we utilize chaos engineering to become better cloud native engineers and improve incident response. Let me first introduce myself. My name is Eran, and I'm leading cyber security engineering at Eran. I'm an engineer, problem solver, and love sharing my knowledge with others. So before we start, I would like to start with this one. What are you going to gain out of this talk? I would like to share with you how we leverage chaos engineering principles to achieve other things besides its main goal. We wanted at the beginning to bring more confidence to our engineers who are responding to production incidents, and in addition to that, train them to become better cloud native engineers, as it requires additional expertise which isn't just the actual programming to ship your code somewhere. I would like to share with you how we got there, what we are doing, and how it improves our engineering team's expertise. And one more thing, you might ask yourself, why is this title on Call Like a King? It's a series of workshops I composed at Siren, which at the beginning I must admit meant to bring more confidence for engineers because during their on-call shifts. But later on, it became great playground to train the cloud native engineering practices and share knowledge around it. During this session, I'm going to share with you what we are doing in such workshops. So stay with me. Let's start with the buzzword cloud native, as the definition I copied from the CNCF documentation, which, how they call it, the cloud native definition. I've highlighted some of the words there. While you read the definition, you see the words scalable, dynamic, loosely coupled, resilient, manageable, observable. At the end, you see something that I truly believe in, and I'm trying to make it in part of every culture of any engineering team that I join. As engineers, we deliver products. For the definition, as you see, this is what it brings as a result. Engineers can make high impact changes. This is, in my opinion, what every engineering culture should believe in. Make an impact, and as a result, you will have happy customers. The evolution of the cloud native technologies and the need to scale engineering leading organizations to restructure their teams and embrace new architectural approaches, such as microservices. We're using cloud environments that are pretty dynamic, and we might choose building in microservices to achieve better engineering scale. You should remember, just as a side note, microservices are not the goal, but we use that, the cloud, and other stuff as tools to scale our engineering and end product. As your system scales, your system probably becomes more and more distributed. Distributed systems are by nature challenging. They are not easy to debug, they are not easy to maintain. Why it's not easy? Just because we ship these pieces in a larger puzzle. 2 years ago, I wrote a blog that is trying to describe the engineering evolution at a glance. I think that the role of the engineers grown to be much more bigger. We're not just shipping code anymore. We design it, we develop it, we release it, support it in production. The days that we had to throw artifacts on operations are over. As engineers, we are accountable for the full release cycle. If you think about it, it's mind-blowing. We brought so much power to the engineers, and with great power, we should be much more responsible. You might be interested in the blog that I just mentioned and I wrote back in 2020. I just talked about the changes and the complexity, but we should embrace these changes. These changes enable teams to take an end-to-end ownership of their deliveries and enhance their velocity. As a result of these evolutions, engineers these days are closer to the product and the customer needs. In my opinion, there is still a long way to go, and companies are still struggling how to get engineers closer to the customer to understand in depth what is their business impact. We talked about impact, but what is this impact? Engineers need to know what do they solve, what their influence on the customer, and know the impact on the product. There is a transition in the engineer's mindset. We ship products and not just code. We embrace this transition, which brings with it so many benefits to the companies that are adopting them. On the other hand, as the team and the system scales, it becomes challenging to write new features that solve a certain business problem, and even understanding the service behavior is much more complex. Let's see why it's complex. The advanced approaches that I just mentioned bring great value, but as engineers, we are now writing apps that are part of a wider collection of other services that are built on a certain platform in the cloud. I really like what Ben is sharing in his slides. I would like to share it with you. He's calling them deep systems. Images are better than words, and this pyramid in the slide explains it all. You can see that as your service scales, you need to be responsible to a deep chain of other services that this service actually depends on. This is what it means. We are maintaining deep systems. Obviously, microservices and distributed systems are deep. Let's try to imagine just a certain service you have. Let's say that this is the order service. What do you do in this order service? You fetch data from one service, and then you need to fetch data from another service. And you might produce an event to a third service. The story can go on, but to understand the concept. It's just complex. Deep systems are complex and you should know how to deal with them. As part of transitioning into being more cloud native, distributed, and relying on orchestrators such as Kubernetes at your foundation, engineers face more and more challenges that they didn't have to deal with before. Just imagine this scenario. You are on call, there is some back pressure that brings your SLO targets, there is some issue with one of your availability zones, and third of your deployment couldn't reschedule due to some node availability issues. What do? You need to find it out, and you might need to point that to your on-call DevOps colleague. By the way, DevOps may be working on that already, as it might trigger their SLOs as well. This kind of incident happen, and as a cloud native engineer, you should be aware of the platform you are running. What does it mean to be aware of that? You should know that there are AZs in every region, your pod affinities are defined in some way, and the pods that are scheduled have some status. The cluster events and how you read the cluster events in case of such a failure. This was just a particular scenario that happened to me and might happen to many of you before. As you see, it is not that's just your service anymore. It's more than that, and this is what it means to be a cloud native engineer. As I said already, being cloud native engineer is fun, but also challenging. These days, engineers aren't just writing code and building packages, but are expected to know how to write the relevant Kubernetes resource YAMLs, use HELM, containerize their app, and ship it to a variety of environments. It is not enough to know it at a high level. Being cloud native engineers means that it's not enough to just know the programming language you are working on well, but you should also keep adapting your knowledge and the understanding of the cloud-native technology that you are depending on. Besides the tools you are using, building cloud-native applications involves taking into account many moving parts, such as the platform you are building on, the database you are using, and much more. Obviously, there are great tools and frameworks out there that abstract some of the complexity out from you as an engineer, but being blind to them might hurt you someday or maybe not. If you haven't heard of the fallacies of the distributed computing, I really suggest you to read further on them. They are here to stay, and you should be aware of them and be prepared. In cloud, things will happen. Things will fail. Don't think you know what to expect. Just make sure you understand them, you handle them gracefully, and embrace them. As I said, they will just happen. We talked a lot about the great benefits and also the challenges. So we had to deal with these challenges. Let me explain to you what did we do to cope with these challenges. So we utilized chaos engineering for that purpose. We have found this method pretty useful, and I think that this can be nice to share with you the practices and also with others. Let's first give a quick brief what is chaos engineering. The main goal of chaos engineering is, as explained in the slide that I just copied from the Chaos Principle website. The idea of the chaos engineering is to identify weaknesses and reduce uncertainty when building a distributed system. As I already mentioned in previous slides, building distributed systems at scale is challenging, and since such systems tend to be composed of many moving parts, leveraging chaos engineering practices to reduce the blast radius of such failures proved itself as a great method for that purpose. So I created a series of workshops called On King. These workshops intend to achieve two main objectives: train engineers train engineers on product failures that we had recently, and train engineers on cloud native practices, tooling, and how to become better cloud native engineers. A bit on our on-call procedure before we proceed. We have weekly engineering shifts and a NOC team that monitors our systems 24/7. There are three alert severities defined: severity 1, severity 2, and severity 3, which actually define from the business impact alerts to the actual service owner alerts monitor. We have alert playbooks that assist the on-call engineer while responding to an event. I will elaborate on them a bit later. In the case of a severity 1, the first priority is to get the system back to normal state. The on-call engineer that is leading the incident shall understand the high-level business impact to communicate. In any case, that there needs to be a specific expertise to bring back into the functional state, the engineer is making sure the relevant team or service owner are on keyboard to lead it. These are the tools that the engineer got in the box to utilize in case of an incident. Pretty nice tool set. Now that we understand the picture, let's drill down into the workshop itself. The workshop sessions are composed into three parts. We have the introduction and the goal setting. Then we might have to share some important stuff that have been changed lately and start the challenge right away. Let's dive into each one of them. The session starts with a quick introduction of the motivation. Why do we have the session? What are we going to do in the upcoming session? And make sure the audience are aligned on the flow and agenda. It's very important to show that every time, as it makes people more connected to their motivation and understand what is going to happen. This is part of the main goal. You should try to keep the people focused and concentrated, so make sure the things are clear and concise. Sometimes we utilize the session as a great opportunity to communicate some architectural aspects, platform improvements, or process changes that we had recently. For example, updates to the on-call process, or core service flow adaptations, and much more. We work on maximum 2 production incident simulations, and overall session time shouldn't be longer than 60 minutes. We have found out that we lose engineers' concentration for longer sessions. If you work hybrid, it's better to do this session when you are in the same workspace, as we have found this much more productive. The communication is making a great difference. Let me share with you what we're doing specifically in this part, which is the core of the workshop. I think that this is one of the most important things. Our Oncology King workshop sessions are usually trying to be as close to real-life production scenarios as possible by simulating real production scenarios in one of the environments. Such real-life scenarios enable engineers to build confidence while taking care of real production incidents. Try to have an environment that you can simulate that incident on and let the people play in real time. As we always say, there is no identical environment to production, and since we are doing specific experiment, it's not necessary to have a production environment in place. Obviously, as more as you advance, it might be better to work on production, but it's much more complex, and we have never done this before. Since we utilize chaos engineering here, I suggest having a real experiment that you can execute within a few clicks. We are using one of our load test environments for that purpose. We started manually. If you don't have any tool, I suggest to not spend time on that. Don't rush to use specific chaos engineering tool. Just recently we started using Litmus Chaos to run these chaos experiments, but you can use anything else you would like to, or you can just simulate these incidents manually. I think that the most important thing is, as I said before, we need to have a playground for the engineers to actually exercise and not just hearing someone talking on a presentation slide. You will be convinced that when they are practicing and not just listening to someone explaining something on a slide, it makes the session much more productive. Right after the introduction slides, we drill down into the first challenge. The session starts with a slide explaining a certain incident that we are going to simulate. We usually give some background of what is going to happen. For example, there is some back pressure that we couldn't handle since specific UTC time. We present some metrics of the current behavior. For instance, we present the alerts and the corresponding Grafana dashboard. You should present something very minimal because this is how it actually happens during a real production incident. Then we give engineers some time to review the incident by themselves. Give them the time to think about it is crucial. They're exercising alone, thinking if they haven't encountered something similar before. This is a very important step. It will encourage them to try find out more information and utilize the know-how to get more information such as gather cluster metrics, view the relevant dashboards, read the logs, and service status. It is a very important aspect. You should understand the customer impact, and it's even more important specifically when you are in an on-call. In case of a severity 1, you should communicate the impact on the customers and see if there is any workaround until the incident is resolved completely. Engineers not always aware of the actual customer impact. It's very good time to discuss it. Pause their analysis from time to time and encourage them to ask questions. We have found out that discussions around the incident is a great place for knowledge sharing. Knowledge sharing can be anything from design diagrams to some specific Kubernetes command line. If you are sitting together in the same space, it can be pretty nice because you can see who is doing what, and then you can ask them to show which tools they use and how they got there. What I really like on those sessions is that it triggers conversations. Engineers tell to each other to send some of their CLIs or tools that make their life easier while debugging an incident. The workshop sessions will teach you a lot on the know-how that people have, and I encourage you to update the playbook based on that. If you don't have such playbook, I really recommend you to have such. We have a variety of incident playbooks. Most of them are composed for major severity 1 alerts. They provide the on-call engineer with some gotchas and high-level flows that is important to look at when dealing with different scenarios. These are how our playbook templates looks like. Drive the conversation by asking questions that will enable you to share some of the topics that you would like to train on. For example, some examples that I have proved to be efficient. Ask an engineer to present a Grafana dashboard to look at. Ask an engineer to share his Kibana logging queries, or ask someone else to present its data tracing and how to find such a trace. You sometimes need to moderate the conversation a bit as the time flies pretty fast and you need to bring back the focus a bit. During the discussion, point your finger on interesting architectural aspects that you would like the engineers to know about. Maybe you can talk on a specific async channel that you might want to share your thoughts about. Encourage the audience to speak by asking questions around these areas of interest that will enable them to even suggest new design approaches or highlight challenges they were thinking about lately. You might be surprised and even add them to your technical deck. At the end of every challenge, ask somebody to present their end-to-end analysis. It makes things clear for the people that might not feel comfortable enough to ask questions in large forums, or engineers that have been just joined the teams, or junior engineers that might want to learn more. It's a great source for people to get back into what has been done, and also fantastic part of the knowledge base where you can share onboarding training process to new engineers that just joined the team. I found out that people sometimes just watch the recording afterwards. It becomes handy even just for the engineers to get some of the tools that are in their belt. So just make sure you record and share the meeting notes right after the session. As you can see, chaos engineering for training is pretty cool. Leverage that to invest in your engineering team knowledge and skills. And it seems to be successful, and at least it was successful for us. So to summarize some of the key takeaways, we found out that these sessions are an awesome playground for engineers. I must admit that I didn't know that I didn't think about chaos engineering for this simulation at the first place. We started with just a manual simulation of our incidents, or just presented some of the evidence we gathered during a time of failure to drive conversation around them. As we move forward, we leverage the usage of chaos tools for that purpose. Besides the training to become a better cloud-native engineers, the on-call engineers are feeling much more comfortable in their shifts and understand the tools available to them to respond quickly. I thought it can be good to share as we always talk about chaos engineering experiments to make better reliable systems, but you can leverage them also to invest in your engineering team's training. Thanks for your time and hope it was a fruitful session. Feel free to ask me any questions anytime. I will be very happy to share more. Thank you.